Hey, computational thinking. Hope you're having a great week. In the two videos for this week, we're going to be first looking at a basic example of how we use Request and BeautifulSoup to pull some data from a Wikipedia page. And this is something you're going to code along with too. And then we're going to look at how we think of objects in the Python language and what that really means. So we're using an example of an object when we create our beautiful soup, as you'll see in this video. And then we need to figure out, like, okay, well, what does that really mean? So I'm giving you a chance to put your hands on the keyboard first, and then we'll learn more about what it is you're doing exactly in the second video. You also have one homework for this week. It's basically like a rework of what we're going to do in this video. So all you've got to do is make a couple changes to the code that we write right now, and then you'll be good to go for the homework. So you might need to do a little bit of Googling, but not too much. All right. Stick around for the video, and I hope you have a great rest of your week. Here we have the Wikipedia page for the planet Earth, and we are going to try to take the first paragraph from this page about the planet Earth and pull it down into Python so that we can have a nice little summary of the Earth in our Python program. I'm going to show you why this can be kind of a powerful thing to do once we get to the very end. Now, the first thing that you want to do is figure out what element on this HTML page is this first paragraph. And in order to do that, you need to inspect the page. So you can do that a couple of different ways. You can right click and go to inspect. I think on a Windows machine running Chrome, it'll say inspect element. If you're on a Chromebook, you should have some kind of inspection option there for your Chrome browser. The other option is you can also press like a F12 on your keyboard. You can press Control-Shift-I on a Windows keyboard. There's a number of ways to get here, but this is really where we want to get. And having this available to us lets us see the actual HTML content of the page. We can use this content to find where our target data is on the page. Now, the simplest tool to use from here is this little guy right here. So we can select any element on the page and inspect it. I'm going to click this, and I'm going to mouse over this first paragraph. So the first thing that you should notice is that at the very top of this info box, it says the letter P. So that tells us it's a paragraph element. We're going to see that BeautifulSoup, the other external library that we're going to use other than requests, has some pretty cool tools that lets us find all of the specific type of element we're looking for. So with that in mind, since we know it's a paragraph element, we're simply going to run with this information. If we were looking to target some more specific data, for example, if we were trying to pull out like this link right here, we could select this and we could use some additional information like the exact link, what ID it's under, what div it's under, but we're not really concerned with that sort of advanced stuff right now. We're just working with the basics. So now that we know we're looking for a P, the next step is to pull this web page down into Python. So what you're going to do is go ahead and copy this link right here and roll on over to a new REPL. Okay, with your web page copied, we are going to start writing our Python code. The first thing that we need is the requests library. Requests lets us pull data from the internet, specifically web pages made of HTML. We can also push data out to the internet. For example, you could post a tweet using requests, but we're not going to be working with that right now. The other library that we need is BeautifulSoup, and in order to get BeautifulSoup, we say this: from BS4 import BeautifulSoup. You might be wondering why these are different, and I'll explain that with a simple example using the random library. So if we type in our console and we say import random, in order to get a random integer, you know that we have to type this. We have to say random.randint 1 to 6. That gives us some random number output. We could also have done this. We could say from random import randint. And then we can call the randint method by typing randint on its own. This is an example of writing code for a specific design philosophy, you might say. This is a subjective thing, how you decide to import your different libraries, what you decide to import from your libraries. But in a lot of cases, when we're dealing with a highly complex library like BS4, Pygame is another example of this. Django, which we develop web applications with, is another example. A lot of times we find this format because the programmer who wrote this or who writes this type of statement typically wants to suggest that we're only using a specific part of the library. We're not using all the features of that external library. Sometimes that can be important and enhances the readability of your code. But again, it's a little subjective, so we're not going to get into it too much right now. But you can use this same format actually to import things from other files, and we're going to learn about that more later on in the year. Okay, so we've got Requests and BeautifulSoup typed in, but you might remember that unlike random, we actually have to install this, or install these external libraries, Requests and BeautifulSoup. So in order to do that, on Replit, all you've got to do is run your code. I'll press Command and Return on my Mac. You can press Alt-Enter, I believe, on a Windows machine and run your code. Okay, so now I've got access to all the features of both of these libraries since they're installed. The first thing we need to do is get our web page from the internet. Typically, I store my web page requests in a variable called resp, and we're going to use the .get method on the URL that we copied. You got to make sure it's a string, just like that. Now, another way to do this, and probably the best practice, is to take this out of the get, cut it out, and then create a constant called URL. Remember, a constant is an all caps variable name for data that will never change. Okay? So we're going to make this a constant URL. That stands for Uniform Resource Locator. It's something we see on the internet and on your computer when you're exploring the file system. You might call it a web address, which is also fine. But that's where we're going to keep this address to the Wikipedia page for Earth, and we're going to call the get method with URL as the argument. So it's the same thing we had before, just written in a little better way. Now let's see what we get. We run this code, we type in resp. We get response 200. This is telling us that we successfully went out and got the web page. If we didn't successfully get the web page, we would have gotten a 404, a 503, or some other kind of error code. But we're really interested in this resp.text. And this is a string containing the entire web page. The reason that we can't really go further with just resp.text, so that's the string, right, is that we can't do a whole lot with strings. They're limited for what we need to do with this little project. So what we're going to do instead is we're going to make some soup using BeautifulSoup. Now, the soup variable can be whatever you want it to be. I just like to call it soup. All right, so this will be a BeautifulSoup object. And in order to make that object, we need the text that we just saw. And we're going to tell BeautifulSoup that the text is HTML. So we want to parse it as HTML. We want to analyze it as HTML. In the next video, we're going to talk more about this idea of creating an instance of a BeautifulSoup object. That's what we're doing right here when we say BeautifulSoup and then include these arguments within the parentheses. Okay, so now we've got our soup. We'll run our code again. So if we type in soup, we see it's basically the same thing, but what's interesting is that the type of data has changed. So I'm going to clear this out real quick once more. And if I type in type of resp.text, we can see that it's a string. If I type what is type soup, we'll see that it's a BeautifulSoup object, or it's a class BeautifulSoup. So this is a totally different tool. And the reason that that's important is because strings have limited functionality for what we're going to be doing, and this BeautifulSoup object has tons of functionality for what we're going to be doing. The next step is to get the paragraph. So let's get the paragraph, getting the paragraph from the Earth page. Cool. In order to do that, we're going to use a handy method from the BeautifulSoup library called findAll. So we're going to say all paragraphs on the page will be soup.findAllP. So this is going to go out and automatically find all the paragraphs on the page. Now if we see what is all paragraphs, you can see that our output got shortened quite a bit, and most of this looks like paragraph text informational data, of which there is a lot on a Wikipedia page. So our end goal was to pull only the first paragraph down. We've basically got every paragraph on the page. So as it turns out, again, using our handy type function to help us out, we can see that type all paragraphs is something called a result set. Now I'm going to tell you, you could easily just go Google this and say, what is a Beautiful Soup result set? And you would find the same thing. But I will tell you that a result set is a lot like a list, meaning it's indexed. So we could say something like all paragraphs 0. Now unfortunately, this isn't the best example because it just so happens that the 0th element, or the first, truly the first paragraph on any Wikipedia page, seems to be just an empty space. In fact, if we say all paragraphs 0.text, it's a new line. So it's basically nothing. What we want to see is that first paragraph. And so if we do a little experimentation, which is always good in code, we'll see that the actual first paragraph is located at the first index. The next step is we want to isolate just the text. We don't want to include all this HTML code because it's difficult to read. So the next thing we'll do is we'll say, okay, we only want the first paragraph, which we saw was at index 0. So we'll say first paragraph is all paragraphs, index 1. And then we are going to print off only the first paragraph dot text. There we go. So now we've got this handy paragraph from the Planet Earth page on Wikipedia. It tells us a little bit of information about the Earth. Now here's some bonus knowledge. You don't have to keep watching if you don't want bonus knowledge, because I think you've got enough info to work on your homework from right here. But I want to give you some bonus knowledge, right? We can actually extend this same idea to make a very powerful program. You might have a buddy, or you may be this sort of person, who whenever someone makes an assertion during a conversation, they say, well, actually, and then they give you the right information, or what they think is the right information. Perhaps you want to play this person for a day, or maybe if you're already this person, you want to be much better at it. But I'm going to show you how we can take this little program and make it so that you can look up any information on Wikipedia and immediately inform yourself at the surface level, which is how most of those people are informed anyway. Not a very high depth of knowledge, just a little bit of knowledge about a variety of stuff, which is okay and fun. So here we go. We are going to call this variable knowledge because that's a funny name for a variable. And we're going to create an input here, and we'll say, what do you want to know about? Okay, so this input is something we are going to end up using right here in our URL. So rather than this being a plain old string, we're going to make it an F string. And then we're going to include some brackets. And we're going to include the variable knowledge. Perhaps you already see where I'm going with this. Now we're going to run our code. We'll say we want to know about Jupiter. Sure enough, we get the first paragraph from the Jupiter page. We'll run our program again. And we want to know about Pluto. Okay. So sometimes it doesn't work because the first paragraph is actually something else. We could write some selection code to fix this, but for the purposes of time, we're not going to do that right now. Let's try another planet. We'll try Mars. Great. So Mars works as well, but we don't have to stick with just planets. We could try something like dog. Nothing for dog. Let's try bear. Nothing for bear either. I think the animal pages are all a little bit different. We could try tree. There we go. So plants seem to work. Tells us in botany a tree is a perennial plant with an elongated stem or trunk supporting branches and leaves in most species. Wow, we are now very informed about the tree. Okay, so this is the first video. In the second video, we're going to talk about this idea of an object and what that really means and how we could use that for a variety of code and how it's one of the most important and fundamental concepts in all of computational thinking.